So we're going to go through these. Now, before I go too much further, I need to take a moment to explain. You already know how to do that. And this is going to become very important later on. And you also already know how to do that. You actually already know how to do factor trees. If you don't know what a factor tree is, you don't remember, think back to like grade 3. And Mrs. Bag Crumble would give you a number, 12, and then she would say, make a factor tree. And you would be like, what's a factor tree? And then Mrs. Bag Crumble would teach you that the factors are two numbers that multiply together to make another number. So you would go, she would say, what are the two numbers that multiply together to make 12? And you would go, they're 2 and 6, Mrs. Bag Crumble. Or somebody would say they're 3 and 4. It wouldn't matter. So you would go 2 and 6. And then Mrs. Bag Crumble would say, can 6 get any smaller? And you would say, it's 2 and 3, Mrs. Bag Crumble. And you would go 2 and 3. And you would draw one of those. You've all seen this, yes? Some of you were taught to draw them horizontally. Some of you were taught to draw them vertically. 3, 4, 2, 2. Some of you were taught to draw them vertically. Some of you were taught other ways to draw them. It doesn't matter because it doesn't matter. The goal is what is important here. It doesn't matter how it looks. What you did with these was nothing, right? Mrs. Bag Crumble would give you a bunch of numbers and you would make trees for every single one of them, yes? And then that was the end of the lesson, right? You wrote a test on trees. And Mrs. Bag Crumble was like, oh, you're so smart, you got your A. Yeah? Okay. That's the problem with math in Canada. This thing that they taught you has a lot of other uses, but they stopped teaching it to you in about grade 4, and then you never saw a factor tree again until now, 6 years later, when they're actually useful again. You understand what I'm saying? It's a bit of a problem. It's kind of like learning to drive and only learning to turn left and then 6 years later learning to turn right. It's kind of dumb. But that's the way we like to teach math in North America. Everywhere else in the world is different. So let us move it along. First of all, I need to remind you of that term. What is a prime number? And it is important because they are the most powerful numbers in the universe. What's a prime number? Everybody knows what it is. Come on, somebody can tell me. Don't say it's a number that transforms and has a real deep voice. It's not that. Although it should be. Really? Pardon me? Yeah, it can't be divided. Why can't it be divided? Because it only has 2 factors, right? Yeah, any number with only 2 factors. Those factors are 1 and itself. So, as a result, we get these very, very powerful numbers. And there's no way to predict when they happen. Mathematicians were just celebrating the fact that they found another prime number. It's like 18 trillion something. It's a huge number. And it has no other factors except for 1 and 18 trillion. There's no way to guess when they're coming. There's no prediction. It's just dumb luck. So the prime numbers begin with 2, which is the most powerful prime number. It is the most powerful number of the list of most powerful numbers. Why? What is it about 2 that makes it very special? Let's write a few more. 3, 5, 7. What's the next one? 11. What's the next one? 13. Oh, surface isn't fixed. Next one. That was a useful update. 17. I'll help you out. 23, and so on and so on. What do you notice about 2? Why is it the most powerful? Yep, it's the only even one. Okay, You guys have done LCM in your youth. LCM for you guys, you know it as lowest common denominator. You've done that to death. So we're going to talk about them in a sec, what they mean. GCF. Oh, I know what I have forgotten to do. There we go. Where is it? There. Get my red dot back. And GCF is something else differently. But to do GCF and LCM, you've been taught how to do it. You know how to do it. But there's a way that you can use these to find these. And many of you will have seen this before, of course, but some of you won't have, especially those of you taking this for the first time. So what I'm going to ask for you to do is do what you already know how to do. Make a factor tree for prime factors only, which means I want my factor tree branches, the branches end at prime numbers. Now this is much like trigonometry. There's no right way to do it, okay? So all you're going to do is build a factor tree of 54, but you're aiming to get to prime numbers, okay? So what are two factors of 54? Brooklyn? 2 and 27 works great. 2 and 27. And I'm going to circle 2. I'm circling 2 because it's a prime number, okay? Then I continue to break it down because 27 is not a prime number, so it can't be at the end of a branch. Everybody understand? So what are some factors of 27? 3 and 9. 3 is another prime number, so I'm going to stop that branch. 9 is not. 3 and 3. And now I've got prime numbers everywhere. Now watch this, please. Probably when you were taught factor trees before, you were taught to write out all the factors. We're in the 10th grade. We don't do that anymore. The prime factorization of 54 is 2 times 3 cubed. Everybody cool? Why? 1, 2, 3 threes and a 2. Got it? Okay, so now let's do 162. Now 162 is a bigger number. When you were doing factor trees and this is back crumble, you probably never went over like 80. Maybe up to 100. 162 is a bigger number. So 3 and 54 works. 3. And then we already know 54, don't we? It's over here. We know it's 3 and 18. We know it's 3 and 6. And we know it's 3 and 2. So what is 162? It's 2 times 3 to the 4th. There we go. Okay? Everybody already knows how to do this, yes? Before I go on, I would like to remind you of a few things. I am sure that your previous teachers have taught you tricks for division. Right? Does anybody know any of them? Here's what I mean by that. If the number ends in 0, 2, 4, 6, 8, what can you divide it by? 2, right? There's all kinds of tricks. Does anybody know another one? Akash? Right. So we know if it's even, it'll divide by 2. Akash knows the one if it ends with a 0 or 5, it'll divide by 5. Who has some other ones? Fawaz. Yeah. The sum of the digits, if the sum of the digits divides by 3, then the whole number divides by 3. So 1, 6, and 2 is 9. 9 divides by 3, so I can divide 3 into that. There's 1, there's 2, there's 3. Haley, you have a fourth one. What is it?
If it's divisible by 2, that can be divisible by 6.
Yeah! If divides by 2 and divides by 3, then it'll divide by 6. Excellent. Does anybody have another one? Ekti. I'm sorry, what? I just can't hear you. Of course, not usually, every time. 5 ends in 0. You can divide by 10. And that's pretty good. There's a bunch more. But that's more than enough to do math, right? If you've got a couple of them. So now that we've got some of those divisibility rules locked in our head, let's talk about what these things are. Greatest common factor is the largest number, and that's what that symbol really means. The largest number that divides into your group. So right now, what's our group for this question? It's 54 and 162. A GCF can be found using prime factorization. Can be found using prime factorization by doing the following. Now, some of you will have seen this, some of you won't. Please pay attention if you haven't seen this before. A GCF can always be found by multiplying all, and I'm going to highlight all the common, not S, I don't need the S, all the common prime factors. And we're going to do that in a minute, even though you already know the answer. I'm going to show you what I mean in a sec. Put a little star by that one. A lowest common multiple is now this is a problem because the lowest common multiple is the lowest number which your group will multiply up to. This is the problem. Kids screw this up because your greatest common factor is smaller than your numbers, but your lowest common multiple is greater than your numbers. So it messes kids up. And this one is a little tricky. An LCM can be found using prime factorization by multiplying all, again, the prime factors. Without repeating. So, here is what I mean. Please read the two definitions carefully. In GCF, you only use the common ones. In LCM, you use all of them, but you don't do any repeating. Okay? And here's what I mean by that. We've already done the prime factors for 54 and 162. And what were they? 54 was 2 times 3 cubed, correct? And 162 was 2 times 3 to the 4th, correct? So now I want my GCF. How do I find my GCF? I multiply all the common prime factors. Is there a 2 in both of them? Excellent. So I use the 2. Is there a 3 in both of them? How many 3's are in both of them? 3. So the greatest common factor is 27. 2 times 3 cubed. The LCM requires me to multiply only all of them, but without repeating. So, does 2 appear in both of them?
Yeah.
How many 2's do I need to multiply? 1, because I don't do any repeating. And does 3 appear in both of them? How many 3's? No. I need to multiply all of the prime factors without repeating. So, if I multiply by 3 3's, does that cover this guy's 4th 3? No. If I multiply by 4 3's, does that cover all of this guy's 3? So I have to do all 4 of them to get 162. Is everybody cool with that? We're going to practice it like 1, 2, 3, 4 times right now. But is everybody good? You do it everything once and once only. Now, some kids prefer to write these out. They feel this works better for them. 2 times 3 times 3 times 3. And 2 times 3 times 3 times 3 times 3. And then they say, okay, there's a common, there's a common, there's a common, there's a common. So my GCF, once all this shows up, my GCF is 2, 3, 3, 3. Okay, 2 times 3 times 3 times 3. And then my LCM, they got to count everything without repeating. Well, this row covers all of those. So I got to do the whole row. So my LCM is 2 times 3 times 3 times 3 times 3. I don't care which way you do it. It's up to you. Cool? All right. Turn the page over. Do the very first one. 36 and 120. So I got to break it down. And remember, there's no right or wrong way to break this down. So, if you didn't copy mine, you just did it yourself, chances are your factor tree looks a little different than mine. Right? You probably didn't start with 12 and 3. If I know most of you, you started with 9 and 4. That's my guess. Or 6 and 6. I bet nobody used 12 and 3. Really? Most people don't bother because they're not comfortable with their 12 times table. But the point is, as long as you go to a prime number, you're going to get the right answer, yes? Doesn't matter how you start. So now, if I want to GCF that, I need everything that's common, yes? Okay, so is there a 2 that's common to all of it? How many? 2 of them. 2 squared. Is there a 3 that's common to all of it? How many? 1. So the greatest common factor is 2 squared, which is 4, times 3, which is 12. The LCM, I got to count everything, but only once. How many 2's do I have to count to cover everybody? 3. How many 3's do I have to count to cover everybody? 2. Anything else that I have to count? The 5. So that's 8 times 9 is 72, times 5 is 360. Is everybody good at GCF and LCM? Okay, try the next one. 18, 24. Break it down however you wish. Yo. Yeah. We usually write the small number first, but it doesn't matter. Right? Not at all. But usually in math, we like things in order. You know, math guys are nerds. Right? That's why math guys have so much trouble with the Star Wars movies, because it was 4, 5, 6, then 1, 2, 3. And now we're doing 7, 8, 9, but with those kind of half ones in between. It's a super pain in the ass for math guys. Because we're geeks, and Star Wars guys are geeks, but the counting messes us up. So, what's my GCF? What's common to both of them? How many 2's? 1, 2. How many 3's? 1, 3, so the answer is 6. Now count everything once. How many 2's do I need? 3 of them. How many 3's do I need? 2 of them. To get 8 times 9, which is 72. Is everybody good? What would happen if I gave you 3 numbers? What would you have to do? Same thing, except you're trying to find all 3. What if I gave you 6 numbers? Same thing, you're just counting 6. You guys do the last 2. It should take you like 5 seconds. Can everybody do it? Yeah? Okay. I'm going to shut up because you have a test in half an hour. We have a break in half an hour and then a test. So right now I want you working on page 90, or you are working on trig review. Okay? I'm keeping it very light this morning so you can relax and prepare for your trig test. Okay? Page 90 will not take very long. You. Of course not. The question David asked, in case anybody didn't hear, is do you have to do this the way I do it? Of course not. If you've been taught another way, go ahead. I don't care. As you can see, I don't even use factor trees anymore.